So as I told, P is promotional key element of the first level node, and similarly W is the promotional key element of the right hand side. So here first level is called as no root node, next level is what, child nodes. See, in the both the child nodes, the highest element of the will be taken as the upper level key. So like this way, when we go on creating to the next level node, we always take the highest element of that node to the next level, so that will be stored as a upper level key node. That will be stored as a upper level key level node. And see here, we have done it. So mainly when you go for the splitting of the key, suppose if you want to insert the two keys but maximum allowable space is only one node, how can you accommodate the new key? At that time we go for splitting of the nodes. At that time the two new nodes will be created. At that time, the what is the feature we need to maintain? Every node we can have minimum number of key values, hence we are splitting the node. Hence, so cleared, maximum we can have 4, minimum we can have 2, and if it is we cannot accommodate, then we can create to the next level. Next level, when you create, we send the highest key element as the promotional key element. Next we go on creating the B tree. Okay, next how it will be inserting will be working out. We will go on checking. Suppose if you are given with the 4 key element CSDT. So first thing, before inserting, what you do, we go on with the sorting. Initially C will be occupying the first node. Next comes S. So next comes D. Then at that time what happen? Interchanging will be happening because sorting will takes place. C, D, S, T. Suppose if you want to insert A, for example, but here already 4 nodes are full, A cannot accommodate, and we need to check out where we can go for A. A will be coming first now, hence A will be split into the first half node. Next, at that time AC will be occupied in the next level. There D is the highest element, that will be sent as the upper key element, and here T is the highest element, that will be sent as the upper level. This is how we are creating the new node. And like this way, whenever go on creating, see here, for every node, so what I told, you are having a 4 node. For every node you can create a maximum 4 nodes. So every level, first level you are having 1, next level maximum how many nodes you can create? 4, means each you are having a 4. Like this way you go on splitting the nodes, and there is a redistribution will be takes place. Okay, and here how you can define the properties of the B tree. Maximum you can have M, and every page except root and leaves, at least you should have what, M by 2. Minimum it should have 2 resonant, and root it should have at least 2 values, means minimum value should be there, and all the leaves should be appear in the same level. Then the leaf forms a complete order index associated data file. Okay, this is the definition of the B tree. And how you can say that the worst case search, as you go on every level, it should have minimum 2 number of keys, and it can go to the n level. Hence the formula is what, 2 raised to m slash 2 raised to d minus 1. So this is the number of keys we go on searching. Okay, next we comes for the concept of deleting. It should have 4 rules. First rule, it should state that if a node is having a more than minimum number of keys, and if the key is not, suppose in the first level you are having what, C, D, S, T, assume it is for example A, B, C, D, and you are deleting C. A, B, C, D is the 4 level node, and D is what, your promotional key, that is stored in the upper level node. Suppose if you want to delete C, that C is the simplest element, it is not the promotional key element. At that time simply you are deleting that key, you are not making any updation. That is the first rule. And suppose if it is having a more than key, suppose A, B, C, D as example, again I will be telling, if you are deleting the D, that D is called as what, the promotional element. Hence if you delete D, then C will become promotional. Hence in the upper node also you need to delete the D, and you need to take C as the upper node inputs. This is the one thing. Next, if you are having 2 nodes, how you can merge it? You are having 2 nodes. In one node you are having what, A, B, C, D. Next in one more node you are having D, E. Suppose here C is the promotional key element, here E is the promotional key element. Suppose if you delete the E, at that time what happen? The D will be directly combined with this left hand side node, it will form ABCD. This is called a merger. The sibling will be merged. And similarly, how the redistribution will be takes place? And how it will be takes place, we'll see. Suppose if one sibling you are having a minimum number of keys and one more you are having extra keys, then you go on distributing the keys. The largest element will be taking as the upper level. So these are the 4 rules we are following for the deletion. Next, redistribution is nothing but what? Maintaining the tree in the balanced formats. That we are calling it as what? Redistribution. So redistribution avoids splitting or merging, so it redistributes there itself, means that is nothing but what? Sorting or adjusting in the node itself. That's we call it as what? Redistribution. And finally we come with one more solution, that is B star tree. So in the B star trees, again it is having a same rule, it is having a maximum m descendants, but the root node except the page node, root should have 2m minus 1 by 3 descendants. The root has at least all the remains same. So this is about the properties of the B star tree. Okay, clear? So we've seen what do you mean by B tree and why you are going for the B tree creation. See this problem you are getting CDST. So how we can create? Initially you go on sorting and upper level nodes will be updating, and this is how we can create the problem. And regarding this problem, detailed steps I will be making the WhatsApp, so you can go through that problem. And regarding the explanation, this is the completion of your third module. Okay, so third module mainly you are concentrating on this chapter, that is AVL tree, paged binary tree and B tree. Okay, so all the things have been covered, so you can go through it, and regarding in detail you can go through the notes. Okay, so in these concepts you can getting important questions are explain B tree with an example. Next the deletion process in the B tree. Next, what do you mean by redistribution? And next, what do you explain the paged binary tree, explain the AVL tree. Thank you everyone.